Okay, in this video, we are going to be doing AP Calculus Review Quiz number 5. So let's take a look at the questions. Number 1, write the equation line tangent to y equals cosine of pi x over 2 plus 4 pi x squared at x equals -1. So we're going to need to know the value of the function, we're going to need to know the derivative, and then the value of the derivative. Then we'll write the equation. So for the value of the function, that's going to be just y of -1, which will be the cosine of negative pi over 2, which we know is 0, and then plus 4 pi times -1 squared is +1. So the cosine of negative pi over 2 is the same as the cosine of 3 pi over 2. You have to memorize the unit circle because that will help you know those values. So that's 0 plus 4 pi, so we are just getting 4 pi. Now we need to find the derivative. So that's going to take the chain rule, right? The derivative of cosine of pi over 2x is going to be negative pi over 2 by the chain rule, and then sine of pi over 2x. And then 4 pi x squared is just going to give you 8 pi x. We need to evaluate this at -1, so I will use that notation. And then the sine of negative pi over 2 is going to be the sine of 3 pi over 2, which is -1, and then obviously minus 8 pi. And so this is -16 pi over 2 plus pi over 2, so -15 pi over 2. And then we will write the equation of the tangent line because that's what we were asked for. So write it in point slope form and leave it and move on to the next question. All right, given that f of -3 is 2, f prime of -3 is 5, and f double prime of x is less than 0 for all x. We want to approximate f of -2.8 using a locally linear approximation. That's another way of saying a tangent line approximation at x equals -3. So we're doing the tangent line again. And this time we're just like given everything. So let's just plug in y minus 2 equals 5, quantity x plus 3. We need to approximate. So this is a big deal. F of x, or f of -2.8, is approximately, if we don't use the approximate symbol there, we're going to lose a point. So that's one of those things where like, that's the difference between getting a 5 and a 4 or a 4 and a 3 or whatever, is knowing those little things and actually doing them. So you have to use the approximate sign there. It's going to be 2 and then plus 5 times -2.8 plus 3 is just 0.2. And then 0.2 of 5 is 1, so 2 plus 1 rather, is 3. There we go. Is your approximation an over or under estimate? I don't think you should try to think your way through this. I think you should draw a picture to figure it out. But we know that f double prime is less than 0, which means our curve is concave down, which means our tangent line is above. So we definitely have gotten an overestimate. So let's just write those things down. So since f double prime is less than 0, so this is how we know that f is concave down. And since we know that f is concave down, we can say that the tangent line for sure is giving an overestimate. And we didn't have to like work that out. We just drew a picture, looked at it, and we're like, yes, you should definitely do that. So these are all exam tips, things you can do to make sure that you get all the points you deserve. Let's take a look at the next question. Number 3, find the average position of a particle moving along the x-axis given its position at time t is given by, I feel like I could have written that a little tighter, but whatever. X of t equals 3, the quantity 2t plus 1 to the 5th for t equals 0 to t equals 1/2. So that's our interval. All right, so average anything. So average position is the average value of position. So we're going to do the integral of position divided by the interval on which you are finding this position. So it's going to be the integral from 0 to 1/2 of the position, so 3 quantity 2t plus 1 to the 5th dt, over 1/2 minus 0. Integral over interval. So when you're asked for average blank, replace that in your mind with average value of blank, and it'll be a lot easier to work out. I'm going to just like flip. So it's all over 1/2. I'm going to rewrite it as 2 times the thing. And now we have to be really careful on this one because it's a little devious with what happens here. There's that 2. Then to reverse the chain rule, there should have been a 2, so another 1/2. Then to reverse the power rule, we'll have that 3 that's there as a coefficient over 6, which is 1 more than 5, and then 2t plus 1 to the 6. So watch out, there's like extra things there. There aren't really, but it feels like it. And we're going from 0 to 1/2. All right, when we do this, you got 2 times 1/2 is 1, and then 3 over 6 is 1/2. All right, we have to plug in 1/2. That's going to give us 2 to the 6th. Then when we plug in 0, we get 1 to the 6th. So 2 to the 5th, I don't know why 2 to the 5th always is stuck in my head as being 32, but 2 to the 5th is 32, so 2 to the 6th is 64. So we have 1/2, and then we will have 64 minus 1. So we actually just get 63 over 2, and I'm just going to leave that because not going to get better. All right, so that's our average position. Let's take a look at the next one. So this has 3 parts. The graph of f of x is shown above. So we're looking at the graph of f of x. Given that g of x is the integral from -1 to 2x f of t dt, we want to find the x-coordinate of each point of inflection of g of x, and we want to justify. Okay, so first up, we need to know what g prime is. So g prime, second fundamental theorem, is going to be plug in the upper bound times the derivative of the upper bound. So we take the 2x and plug it in, then multiply by the derivative of 2x. We get this. All right, now, we're definitely looking at the graph of f. So we're going to have to connect that to f of 2x in a second, but let's just worry about f. If f was the derivative, where would there be points of inflection? Well, they'd be at the relative extrema. So here, 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 and here, here, here. 4 heres, however that works out. So at -2, at -1, at 0, and at 4. All right, so I'm going to say that f of x has relative extrema there. There we go. Now, actually, g prime is f of 2x times 2. So for f of x, it's x equals -2, -1, 0, and 4. For f of 2x, that means that 2x is -2, -1, 0, and 4, which means that g prime, which is f of 2x times 2, g prime will have relative extrema at half of the values that we previously found. So g prime has relative extremas at x equals -1, -1/2, 0, and 2. Just take those values, -1, -1/2, 0, and 2, plug them into f of 2x, and see what it gives you for f of x, right? So if I take -1, I'll do f of 2 times -1, so f of -2. Look at the graph of f at -2. There is a relative extrema. So that's the logic behind how this is working. And you can do that with all 4 of them. So I still need to finish the problem. So I've said g prime has relative extrema at those points. But what does that mean? That means that g of x has points of inflection at those values. So this question was a little bit tricky. Not many people, well, no, more than half of people actually divided them and got it correct. But a lot of people just wrote down what f had going on, and we needed to know what f of 2x had going on. So let's take a look at the next one. Write the equation line tangent to, so the function here has switched, I think, to a different, yeah, this is a slightly different function because this is, we want the tangent line to g of x equals 4 to 2x of f of t dt. The last one was from, I think, -1 to 2x. And we want to do this at x equals -1. That didn't really fool anyone on the quiz, but be on the lookout for that. Make sure you're using the correct function when you're answering things. We need to know what g of -1 is, and then we'll need to know what g prime is, and then we can do the problem. So let's see. G of -1, just sub right in. It's going to be the integral from 4 to 2 times -1, so -2 of f of t dt. You realize immediately this is an issue because 4 is bigger than -2, so we're going to flip the bounds and change the sign. So negative, we're going from -2 to 4, f of t dt. This allows us to just go from left to right as we find our areas and our signed areas. So now we got to do that. So up here, that's our interval. I like to go to the graph and just put those bars up so that I know where to start, where to stop, and I don't worry about anything else. So I have this. Let's just find some things. So this is -1.5. This is -0.5. Those two just cancel, so we don't really have to worry about it. And then this will be 2 and then 3, so 5. All right, so we are going to do just accumulate all of those signed areas. So this will be the negative of, and then -2 plus 5. So it's the negative of 3, -3. All right, let's do g prime. So I'm going to rewrite. I'm using second fundamental theorem over and over again. That's a really common theorem to be using, especially on these kinds of problems. So plug in the upper bound times the derivative of the upper bound. And now we need to find g prime of -1. So g prime of -1. I'm a big fan of writing out all of this work. I think you should. So this will be 2 times, when we get to, so we need f of -2. F of -2 you can see is -3. So this will be 2 times -3, which is -6. And now we are ready to write the tangent line. So therefore our tangent line, point slope form, write it down, don't look back. let's take a look at the next and I believe the final part of this. Given that g of x is the integral from 1 to x of f of t dt, so this is actually a simpler function, which makes sense because it's a more complicated thing to do. G of x is the integral from 1 to x of f of t dt. We're going to find the absolute maximum of g of x on the interval from -5 to 5. So -5 to 5 is like the whole deal. It's not a limited thing. All right, so I'm going to use the candidates test because absolute max, absolute min, or the range of the function is always going to be a candidates test type thing. So I need to say that g of x is continuous so that I'm allowed to use it. G of x is definitely continuous because g prime exists for all x in the domain, but I don't want to write that, and I think you can get away with not writing it. But I'm going to say, therefore, the absolute max is going to be at an endpoint or a critical point. Now we got to do some work. So mostly the work will be, we need a table of values, we need the endpoints and the critical points. So the endpoints are -5 and 5. The critical points are -3.5, -1, and +1. So I'm going to fill in all of them. I'm aware that a maximum can only occur at a critical point where the derivative goes positive to negative, but it's like more annoying to write that than it is to just find all these values. So I'm going to just find all the values. All right, so we know, because we're supposed to start at 1, the integral from 1 to 1 is 0. We can fill that in immediately. Now we just need areas. So this is going to give us 1/2, 3/2, 3, so 9/4. This is the exact same region, but negative. This region, -3/2. Overall, that's -1. And then this one, I divided up a little. So you get a 0.5, you get a 5, and then you get a 2.5. So we have all of our values. All right, if I'm going forward from 1, right, the integral from 1 to 5 is just add up 0.55 and 2.5, so that's going to give me 8. Now, if I went backwards, so imagine to get to -1, if I went from -1 to +1, I would accumulate -1, that blue region. But since I'm going the wrong way, instead of accumulating -1, I'm going to reverse that and I'm going to add 1. So if I went from left to right, it would be -1. Going from right to left, it's +1. So I add 1. And now just think, like if I'm at 1 at -1 and I go to +1, I have to subtract 1 and it takes me to 0. So it does make sense. I do that a lot while I'm doing these problems. For the next value, I'm going to switch to decimals because I think it's easier. -2.25 minus 1.5 for like the total negative triangular region there. -3.75. So if I was going from left to right, I would lose 3.75, but I'm going from right to left, so I'm going to gain 3.75 to give me 4.75. And then for the last one, if I was going from left to right, I would have gained 2.25, but I'm going from right to left, so I'm going to lose 2.25. So I get this. All right, so now I should have this table in my work, and it's not really obvious that it is, so I'm going to move it. We have this, and from here we can just see the biggest value in the table is 8, so that's actually our answer. So the absolute maximum is 8 at x equals 5. The question is really asking you to answer that the maximum is 8. I always give both answers if possible, because what if I misread the question? So the answer is really the absolute max is 8. The answer is all of this work, but 8 is the value. It is at x equals 5. And then I just want to say by candidates test. All right, that's the entire quiz. I hope this was helpful, and good luck.